Here we're going to talk about the effective nuclear charge. This can be kind of a confusing topic, but it is responsible for a lot of periodic trends that we'll be talking about in the future. So it is vital that we know what this is. So the effective nuclear charge is a little bit different than the nuclear charge. You're familiar with the nuclear charge already because this is just based on the number of protons in the nucleus. Remember, protons are positively charged. So this nuclear charge is that positive charge associated with the nucleus. We have electrons in these many electron systems. They are partially shielded from that positive charge in the nucleus by other electrons in the atom. We know that these electrons occupy different locations. Some are closer to the nucleus, some are farther away, based primarily on their principal quantum number. But some of these electrons will be shielding other electrons from essentially feeling that full effect. This can be accounted for in what's called the effective nuclear charge, sometimes called Z effective or written ZEFF. That is the sort of positive charge that is actually experienced by that electron in an atom. So the effective nuclear charge is actually less than the full nuclear charge because of the shielding. All electrons do shield one another to some extent, but the core electrons do a much better job of shielding than valence electrons. That's because those core electrons are a little bit closer to the nucleus, so those outermost electrons will be shielded from the nucleus by these core electrons. So oftentimes when we're talking about Z effective or the effective nuclear charge, we're most interested in those valence electrons. So because of this, the Z effective increases steadily from the left to the right on the periodic table. That's because the number of core electrons remains the same. You still have that same noble gas core that we've referred to in the past, but the number of protons, Z, are increasing as you're going from left to right, and therefore also one extra valence electron is being added as well. So you're getting a slight increase in the positive charge associated with the nucleus, and you can think of it as the negative charge associated with those valence electrons. So Z effective is increasing in doing so, and this will affect a lot of periodic trends, like we'll talk about in the near future. So this is an example. Here we're going lithium through fluorine across the periodic table, where Z here is the number of protons, and the Z effective, which again is often with reference to the effective nuclear charge felt by a valence electron. You can see that that number is also increasing from left to right. We do have an equation for it, which is conceptually what we've already talked about. Z effective is equal to the nuclear charge Z minus some shielding constant. And that shielding constant can be calculated, but we're not really going to be calculating that. It does depend a little bit on what type of core electron we're referring to. Different orbitals we know also have different shapes, so this can also affect how well those core electrons are shielding. But this is a topic for future class potentially. So this is how Z effective, those numbers are actually calculated. The change in Z effective as we move from the top of a group to the bottom is less significant than the change as we move across a period. And this makes some sense because of these periodic trends. We have a similar number of valence electrons versus protons in a nucleus. Those differences aren't changing that much going from top to bottom, but from left to right, we do see a large increase. Okay. So since each time you step down on that group, like I had mentioned, there is a large increase in nuclear charge, but you also are adding the same number of core electrons. So they kind of offset each other. And that's why that vertical trend doesn't really change too much. So when we talk about Z effective, generally we are going to use that rationale for the left to right trend, not so much a vertical trend.